All right, hey, more Lewis dot structures. We're going to start looking at the shapes of molecules. One thing I'll be sending you is this piece of paper right here, shapes of molecules. It'll have some sketches. If it's three-dimensional, this will show you how to draw a three-dimensional sketch. Also tell you the name of the shape of the molecule, okay? So let's start with BH3. Hopefully you looked at that other video and you have a sense of how to approach this. Boron has 3 valence electrons. So 3 valence, 1, 2, 3. Hydrogen has 1. Lewis dot structure looks like that. What's unusual about that? Around boron, there's only 6. So that's under the octet. Beryllium, and boron can be under the octet, okay? All right. Now, these are electrons. These dots are electrons. So what do you think these 2 electrons are doing to these 2 electrons? And what do you think these 2 electrons are doing to these 2 electrons? And what do you think these 2 electrons are doing to these 2 electrons? Starts with an R? Yeah, repel. They're repelling. So what this is really going to look like is this. We're going to have these electrons, these bonds, are going to try to get as far away from each other as possible. And we call this shape trigonal planar. Okay? Again, that'll be on the shapes of molecules sheet that I'll send you. How about, there's something else that's kind of important here. How about these bond angles? What those angles between, like this HBH angle, HBH. How about that angle right there? And that HBH angle. They look like they're the same, right? So what do you think? Think of 360. Think of a circle divided into 3 sections. 360 divided by 3. Yeah, 120. 120 degrees each of those. The bond angle, the HBH bond angle is 120. Okay? Trigonal planar. Let's look at methane. We have, of course, it's going to look, we know it looks like that. Now, there's 3 atoms connected to the central atom. And if these electrons are going to try to get as far away from each other as possible, 90 degrees is not going to cut it. They can get further away from each other. So it's actually going to be 3-dimensional. So it's going to look like this. Here is what methane would look like. The shape is tetrahedral. This is tetrahedral. You notice that it's 3-dimensional. There's a hydrogen coming out. This is a hydrogen. There's no balloon for the central atom, but this would represent a hydrogen, tetrahedral. Balloons are great at showing this VSEPR model, the shape of molecules. I forgot to show you the trigonal planar. If you just, and I'm hoping my dog Casey doesn't. Here's trigonal planar. You just tie 3 balloons together and they just pop into this place. They just get as far away from each other as possible, just like these hydrogens want to. And of course we get the trigonal planar there. Tetrahedral. Okay, so what I'd like to do is show you how to draw this 3-dimensionally. So let's put this aside. Casey, no. And what we're going to do is that balloon that was coming out toward you, we're going to use a wedge like that to show that this hydrogen, we want this hydrogen to look like it's in front of the whiteboard. There were 2 balloons going away from you, so we're going to draw those like that. We're going to draw the H's a little smaller. If it's smaller, it looks like it's farther away. And H here. And then what we're going to do, we'll use a different color, and we'll draw the places where the planes come together. So I'm going to draw that. So I'm hoping that looks 3-dimensional. You're going to be responsible for drawing these structures 3-dimensionally, okay? These bond angles, they're all the same. It turns out that they're 109.5. So these angles here, 109.5 degrees. Mathematically, you can figure that out. Maybe I'll have some of you try to do that. This is called tetrahedral. The shape is tetrahedral. The shape, structure, tetrahedral. Tetra means 4. Hedral means face. So if you think of about 1, 2, 3, 4 faces to that. Okay? It's a triangle-based pyramid. Another way of thinking of that. All right, moving on. Let's check out ammonia, NH3. So we look at that. Nitrogen has 5 valence electrons. Of course, we'd add a hydrogen here, and hydrogen here. All right, so this looks pretty similar to methane, but instead of a hydrogen here, instead of a covalent bond here, we call that a lone pair. Okay, a lone pair. So what we're going to do is take this tetrahedral. I'm going to pop one of these balloons. Now I'm going to pop one of these balloons. There we go. And what I'm going to do is add, a yellow balloon. And the yellow balloon is going to represent that lone pair, this lone pair up here. So let me just tie these balloons together here. Come on. All right, so they don't just pop apart. All right, now I'm going to put this in here, and we've got ammonia. So I want to make sure you understand that yellow balloon is a lone pair. So what I'm going to do is draw 2. Oh, I chose the wrong Sharpie. Draw 2 electrons there. Okay, that's a lone pair. Now the thing about lone pairs, this is important. They repel a little bit more. They push down a little bit more than a bond does. So this lone pair is pushing down on these bonds more than that covalent bond does. So what's that do to that bond angle? That lone pair is pushing down, so these guys get a little closer, that bond angle decreases. That's right. Okay, so you can see that? This is pyramidal, by the way. So let's draw the 3D sketch of that. So we have nitrogen, got a lone pair here. That's what how we're gonna draw that. There's a hydrogen coming out towards you, so we'll wedge that out. 2 hydrogens going away into the board. And then we'll draw the faces. I mean the lines like that. Pyramidal. Okay. This is pyramidal. All right. So we have trigonal planar so far, tetrahedral, and pyramidal. Hey, let's look at H2O, and then I may make a second video showing some of the other structures. So H2O, we of course know that oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Hydrogen goes there. Hydrogen goes there. Maybe that's why it's not linear. See those lone pairs pushing against this? How do we draw this? It's a little tricky drawing. So I have a lone pair up here. Let's have a hydrogen coming out here. Hydrogen here. Maybe a lone pair here. And a hydrogen here. What do you think of that? I think these are a little tricky to draw. This is angular. The name of the shape of this is either angular, or you could say bent. It wouldn't matter. Okay? It's pretty important. These lone pairs are pushing against these covalent bonds. They all try to want to get as far away from each other as possible. Let me see if I can show you a balloon model real quickly. I don't have one set up, so oh, I know what I can do. Let me pop. Where's my toothpick? Hey, we'll do this next time. So, drawing looking at shapes of molecules once you have a Lewis dot structure, and also then looking at the names of the shapes and drawing them three-dimensionally. Forgot to tell you this. This has an approximate bond angle of around 107 degrees. And then this here, this bond angle here, this bond angle right here is around 104.5 degrees. Right? So we draw water like this. We always draw water like this. That bond angle is around 104.5. The reason water is not that like this is because of these lone pairs. These lone pairs pushing down on these bonds, so it's not linear. If it were linear, we wouldn't be here. So, okay, that's all for now.